Hello, anatomy. I felt like it's been a while since we've learned some new stuff, and I know that you're missing the sound of my voice, right? So I thought that we could start off with some review of the skeletal system that we've learned so far, and then I could intro some new stuff for you. And I'll try and stay on track. I get really sidetracked when I don't have people right in front of me teaching. So with the skeletal system, there are a couple of things that we already know. So we've already talked about kind of what the skeletal system is, and we've also talked about the functions of it. We've talked about the axial and appendicular skeleton. You should have recorded those in your notes already a couple of days ago. And then we've also learned about the shapes of bone in that same addition to your lecture notes that you got on Canvas a couple of days ago. But I want to do a quick review of those, and then I want to move forward into some new stuff. The new stuff I want to go over, I want to review the bone cells. So if you remember in the body story video that we watched, that super cool video, I talked about osteoblasts, osteoclasts, and osteocytes. So I want to kind of review and introduce those more formally so you know what they are and what they do. And then I want to talk about bone types, and a lot of times they'll just talk about the two main bone types, but we're talking about the difference in the bone tissue itself, and that's what makes bone types different. And then I want to talk about the anatomy of bone, what it looks like inside and how it's put together, and then bone markings. And those are things that we're going to all be able to add to your skeletons that you've been working on. So just as a review of that, things that we already know, we learned 6 main functions of the skeletal system: support, protection, movement facilitation, mineral storage and homeostasis, hematopoiesis, so that creation of blood cells, and storage of energy. So those are the ones that we talked about in class last week. Then in your lecture, we talked about the shapes of bones, and that should be pretty straightforward, but we've got long bones, short bones, flat bones, irregular, and then there's one more that was not in the lecture that I want you to add to your notes. So go back to this section in your lecture notes and kind of keep track of what I'm talking about and make sure you have it in your notes, and then add that last 5th section that I'm going to talk about here in just a minute on. So when we talk about bones in the body, we have 206 bones in an adult skeleton, and we divide those into categories based on their shapes. So those could be a long, short, flat, irregular, and then the last one that I want to talk about is sesamoid. So a sesamoid bone, not all anatomists consider that a classification of bone. They'll group a sesamoid bone in with something like a short bone or an irregular bone, depending on which sesamoid bone it is. But because of its unique structure, I do want to talk about it and its classification because it could show up on an exam. So when we look at the types of bone by shape and we talk about them, I just want to make sure you kind of have a general definition for each. So over here on the left, talking about long bones, and the example here is the humerus. A long bone is usually more of a cylinder in shape. It's longer than it is wide. But remember that we're talking about the shape of the bone, not its actual size, okay? So long bones can be found in the arms, so the humerus, the ulna and the radius, the legs, things like the femur, the tibia, and fibula can also be found in your fingers, your metacarpals and phalanges, and then in your toes, your metatarsals and phalanges. So long bones, they also have a unique function, and long bones generally function as levers or levers, meaning that they move when muscles contract. So their job is to help move our skeleton. Moving down here to short bones. Short bones are tube-like in shape, and they're usually almost equal in length, width, and thickness. The only short bones in the human skeleton are in the carpals of the wrists and the tarsals of the ankles. So short bones will help us with stability and support. They do help with limited motions, so smaller, more minute motions of the body, but mostly they help provide stability to those ankle and wrist joints and support. Without them, we wouldn't be able to support our weight on our feet / ankles, as well as be able to use our hands in the way that we do. Flat bones over here on the top right, we've got the sternum as our example. they call them flat bones, but that's kind of a misleading term because a flat bone is typically thin. It's also curved a lot of times, so you can't think of it being flat like a paper because it is a thinner bone, but it's also curved to help support the weight of the body. So examples of flat bones, the cranial or the skull bones, the scapula. I know the scapula aren't perfectly flat, but we talked about how they're curved. So the shoulder blades are considered a flat bone. The sternum, which is our example here in the picture, and then the ribs are considered flat bones. And flat bones are generally points of attachment for muscles, or they protect internal organs, or they do both. So they're either going to help be a large surface area for attachment of muscles, or they'll protect internal organs, kind of like these flat bones up in our skull do. Okay, irregular bones, right here, the vertebrae. So irregular bones, they're ones that don't really fit into any of the other categories because of their shape and size, and so they don't fit, and they usually have a more complex shape. So the vertebrae is the perfect example, because they support the spinal cord, and it protects it from compressive forces. A lot of your facial bones are also irregular bones, especially the ones that have the sinuses in them, because those sinuses perforating through give those bones an irregular shape. So if they don't really fit in one of the other above categories, they'll often be classified as an irregular bone. Sesamoid, the one that you guys have not yet heard of, and the example is the patella or the kneecap. A sesamoid bone, they're usually small and round, and they are named what they are because they're shaped like sesame seeds. But these bones generally are formed inside of tendons, so inside that connective tissue that connects muscle to bone. And they're in areas where a great deal of pressure is generated at a joint. And so sesamoid bones are there to protect the tendons by helping them to kind of overcome that force that they might have. So for example, in the knee, there is a lot of force coming through with the knee bending and straightening and the quadriceps contracting and relaxing. And so the patella helps overcome those forces by giving them a better angle of movement, and that's what sesamoids do throughout the body. So sesamoid bones vary in number and placement from person to person, so not everybody's going to have the exact amount. So we all have patella, but there are sesamoid bones found under your big toe, and some people might have 1 or 2 or 3, and some people might only have 1, and so the number is not exact from person to person when we talk about sesamoid bones, which is why they don't usually classify them, because they're not part of those typical 206 unless they're that patella bone. But we usually will find them in the associated tendons of the hands and feet as well as the knees. But the patella is the only sesamoid bone that is found in common in every single person, so it's the only one we count. And then if you look at these next slides, I'm just going to put them up here for your review. These are the notes that I gave you in Canvas in class for your long, short, flat, and I'm just putting these up so that you can pause, write them down if you missed them before. Here your regular. And then I put a chart up here just to kind of go through the main features, the main functions, and some examples of each classification of bone by shape. Okay, so moving forward, those are kind of a review of what we have learned this far. I want to go into some new stuff. So I want to talk about types of bone cells. So if you remember from Body Story, they talked a little bit about the 3 types of bone cells that we commonly find in the body. And so I want to talk about that right now. So we have 3 main types of bone cells. The first one is known as an osteoblast, and we're going to talk about each of these a little bit more in depth. But osteoblasts, if we're talking general, they deposit mineral salts and collagen fibers. So they're going to lay down what we call matrix, and matrix is what forms the basis of bone tissue. And so when we talk about creation of bone tissue, it is done by your osteoblasts. Now, as your osteoblasts, if you remember from the video, as your osteoblasts lay down their bone matrix, they get stuck inside. And when they get stuck inside, you end up getting osteocytes. The osteocytes calcify within that matrix as the matrix hardens, and you get osteocytes, which are those mature bone cells that they can no longer lay down matrix because everything around it has hardened. And so they help form that main structure of mature bone tissue. And then you have the third one that we're going to talk about, and we'll talk about another category as well, but these are the three that you're usually tested on, and that is osteoclast. If you remember, we talked about osteoclast releasing substance that's like acid because it breaks down bone tissue. So when we talk about bone and bone cells, bone has a really small number of cells in the matrix, and the matrix is just mineral salts, and then you have collagen fibers throughout. And they provide, those collagen fibers provide a surface for inorganic salt crystals to adhere. And the salt crystals form when calcium phosphate and calcium carbonate combine, and they incorporate other inorganic salts like magnesium, hydroxide, fluoride, a bunch of other things, and they calcify onto these collagen fibers, and then we get this really hard bone tissue. So bone tissue gets this hardness and strength from the crystals that are formed, and then the collagen fibers give the bone tissue some of the flexibility that keeps bone from being brittle, because we don't want brittle bone, because then every time anything happens they would just break. So we need that, they call them hydroxyapatite crystals, and they're going to keep our bone nice and hard, and then we need the collagen fibers to give us flexibility. So when we talk about bone cells, the osteoblasts, clasts, and cytes, they don't really form a large part of our bone volume, but without them, we wouldn't have bones. And so we talked about these three: osteoblasts, cytes, and clasts. And then we also want to talk about osteogenic cells and what they do as well. So just a quick review here. If we go to this picture, the osteoblast right here is the bone responsible for forming new bone, which is often a question you'll get on the exam. And it is found in the growing parts of bone, and it's also found in the periosteum and the endosteum. And we're going to learn those terms, so come back and remember this, that osteoblasts are found in the periosteum, endosteum, and in the parts of growing bone. Osteoblasts do not divide, so you don't get new divided osteoblasts. They make and secrete collagen matrix and calcium salts, which we talked about. And as this matrix surrounding the osteoblast hardens, the osteoblast is trapped inside. And then when it's trapped inside, its structure changes. And you'll remember from the video, it kind of spreads out, and its little arms start reaching out from one to another. And when that happens, it becomes an osteocyte, and an osteocyte is the primary cell of mature bone. So that's over here. Notice that the shape is a lot different from an osteoblast to an osteocyte, okay? But this becomes the primary cell of our mature bone, and it's the most common type of bone cell. So if they ask you which one's most common, it's the osteocyte. And an osteocyte is located in a space that we call a lacuna, and then it's surrounded by bony tissue. So this is, when you're looking at an osteocyte, it would be within a lacuna, and then the stuff around it would be matrix, okay? So osteocytes, they maintain the mineral concentration of the matrix because they secrete enzymes, and like osteoblasts, osteocytes also do not divide, so they don't undergo mitosis, but they do communicate with each other, and they receive nutrients via what we call a canaliculi, which sounds like canal because that's what it kind of is. It's this channel within the matrix of the bone. So when we show a zoomed in picture in the future, when we talk about bone tissue, there are channels or canaliculi that allow nutrients to make it to these osteocytes so that they can stay functioning. And then they're also able to secrete enzymes that help us maintain a mineral balance within our bone tissue. Okay, so if osteoblasts and sites cannot undergo mitosis, then how do we get new ones if the old ones die? So the last thing comes from what we call this osteogenic cell. So osteogenic cells are what we consider an undifferentiated cell. So it hasn't quite turned into an osteoblast or an osteocyte. It's still going to be able to undergo mitosis. And so these osteogenic cells have high mitotic activity. They undergo mitosis very, very often, and they're the only bone cells we have that divide. And immature osteogenic cells are found in the deep layers of the periosteum and in our marrow, and they will then differentiate. Once they've divided, a lot of times they will grow and change into our osteoblasts. So that's how we get new ones. But once they're an osteoblast, they can't undergo mitosis, and neither can osteocytes. So one thing about bone is that new tissue is constantly formed, and then this old, uninjured, or unnecessary bone is dissolved, and we use it for repair or we use it for calcium release. So our osteoclasts are responsible for bone reabsorption or bone breakdown. And they're found on bone surfaces. And if you look at this one, notice that they're multinucleate. These other ones are singular or they're uninucleate, whereas these osteoclasts are multinucleate. And they originate from monocytes and macrophages, so think white blood cells. They actually don't come from osteogenic cells, which makes them unique. So osteogenic cells will turn into osteoblasts, which then turn into osteocytes. But osteoclasts come from the family of white blood cells, and they continually break down old bone, while in the meantime, osteoblasts are continually laying down new bone. So there's this constant subtle reshaping of bone throughout our life. And so if you talk about bone changing, if you remember the video, it talked about how our whole skeleton is replaced within about 7 years. And if you talk about our skeleton itself, it does actually change quite a bit, even in 1 year, but the whole skeleton doesn't change in 1 year. So here's another picture just showing that osteogenic cell that can turn into an osteoblast, which turns into an osteocyte. But separate from those, we have our osteoclast, which comes from the family of white blood cells and does separate duties. So I just created this chart for you to kind of remember their function and location. Okay, so we're going to pause right there, and then we're going to start a new lecture on bone tissue.